Welcome to this video about the new features of the Dragon game engine. This time I have two things for you. First, the ECBehaviorWorld and support for behavior and state machine extended use for regular elements as well as player actions and behaviors, or AI. So let's first start with the behavior world. The behavior world is a new behavior which has been added based on the experiences I've made with world loading elements in the Epsilon game project. And I've distilled it together in a simpler behavior for public use, which covers typical use cases. So in the Dragon engine, we have the difference that where in other engines, you have to work with these prefab systems to do pretty much everything. Since you can't do combined objects, even for a small object like a person which holds something in its hands, or even like a lamp which is standing on a desk and has a light, you need to use prefabs to make any kinds of composed objects. Dragon engine always had for this the concept of element classes or object classes, which are just a virtual entity, so to speak, which describes something you want to put in your world, but you don't define yet what it is, and the actual content of what this element looks like is then provided by behaviors. So the most parts, or the large amount of things for which you need prefabs is covered by making element classes, which makes your life easier. But at times it might be useful to have the support to load a world and show it in a other world to compose larger things. Like, for example, you have an entire building or an entire complex you want to put into a world without being able to define this as a simple element. And this is what this new behavior world behavior is providing. It's actually just support to load a world file and to add the content at the location where the element is in the world with some additional features. So I have here the example project, and in this example project, I have put here 3 world loaders. The game engine provides the base world element, which simply is an element which has the behavior world added to it. But you can use the behavior world on existing elements yourself or adding it yourself. So here I have loaded 3 times the same world, which I defined sub1 world, which is pretty much just a world which composes of an element, which is this monkey head, a shout trigger, which then prints text on the console, and a trigger touch, which is able to then trigger this shouting on the console. So in this subworld, we have these things. I can quickly show this. So that's all we have here. Just the monkey, we have the touch sensor, and we have the trigger shout. So the idea here is that I can not only insert these objects into a main object, like instancing a prefab in other engines, you can also manipulate their properties. In the game engine, in the Dragon game engine, everything is done using object properties, which are listed here. So you don't manipulate directly parameters, script parameters of objects, but you manipulate their properties. And the properties are then applied to the object in whatever way is required, so that it is much more generic, transparent, and a really thin connection between the artist and the scripter. So what can you do? When a world is loaded with the ECBehaviorWorld, it does not only just instantiate or copy and instantiate the stubs that are defined in this world, so these elements here, but it also allows to modify the properties using a so-called text replacer. The text replacer is able to say, I take the property values, and if I find tags inside, I can replace them. A tag is simply something like here, which is curly brackets and something inside. So what is between a curly bracket is considered a tag. You can technically modify which is the starting and end character for such tags if you need it for your project, but the default is curly brackets. And tags have the form that they start with an action, followed by a double colon, and optional parameters, which are then a comma separated list. If the action has no parameters, it's simply just the action name besides a double colon and finished. So something like this would be just a simple action. So in this case, it is an action called owner, which has the parameter ID. Basically, this means if this is replaced, this entire curly bracelet here would be replaced with the ID, the unique ID, object ID, of the element which instantiated all this entire world. So it's a typical way to make sure that a trigger, for example, you have in your subworld is unique. Otherwise, if you would instantiate them 3 times and you would not use something like this, they would be the same and you get in troubles. But here I use the ID of the instantiating element to make sure that it's unique. It's also the trigger which is used requires this replacement too. And I've also added here as an example a custom replacement. Here I said, okay, the message that is displayed on the console is again this owner action with the parameters property and var poker text. The property simply means that here I'm reading the value of a property of the element which instantiated this world, so the parent, so to speak. And I say use the property with the name var poker text and add it here as text for this. I would also be able to say default text. So if I add another comma and another text behind it, this would mean if this property cannot be found in the parent object, use this text instead. If you don't put this default text, it simply uses an empty string as default text. So here I have total freedom. I can specify a parameter, a property value, which already exists, something like, for example, show message or whatever, or I can invent a totally custom and non-existing property and assign a value to it. You have total freedom. You can either use special characters like a dash or whatever if this fits your system. So with this defined, I can then go back to the hub world. And then I can see here I have used for this first object, not only I've defined which world I want to load, but I've also added this var poker text. As you can see by the exclamation mark in front of it, this is a property which does not exist in any kind of behaviors that this element has. But that doesn't matter. I can add any kind of properties that do not exist if I have use for it. And in this case, I'm going to use it in my subworld to replace things. So you can easily create your own kinds of replacement variables in an object and give them any kind of text. So I have here now objects with 3 different texts, and thus, if I run this now, I will have 3 times this object instantiated, but 3 times with a different text and especially a different trigger. So if I go in the first one, it's the first poker text. The second trigger is again unique with a different run, and the same with the third one. So you can easily load individual worlds files you've created, and also have your custom property replacements. And the nice thing on this system is you cannot manipulate parameters directly, like I want to manipulate the color of some kind of resource which is inside an object inside that world. But instead you just say, okay, I define with my artist what kind of replacements we want to use for the subworlds, which kinds of text, and we simply just modify the properties with it. And with this, we have a much cleaner system where it's very easy to understand how things work and what replacements happen. So even if it's not directly comparable to a prefab system in other engines, which are different in their nature, for the Dragon Gene game engine, this allows to add and load worlds in a much more clean way while still sticking to the powerful element class system which is already in it. So this is it for the world behavior world system with the replacement. You can also take a look at the TRR element class in the game engine repository, and there we'll see all the kinds of replacements you can use. So you can use the ID of the element which has instantiated, or you can use the class name of the element. You can use a property, and you can also use a world property. So world property means if I'm here in this world, I can also define properties which are just belonging to the world. So you can also read those world properties, for example, to set a variable which is true, a replacement which is true for the entire world and not just for individual objects. So this can be useful if you have like, say, you want to have a variable in the world which tells what kind of biome you have or what kind of structures you want to have shown or what kind of theme you want to show, then you can put this in a world and have the fine tuning replacements still in your base worlds. Also, you can add your own. So if necessary, you can create behaviors on your own, which you add, and these behaviors can then add their own tag resolvers to such a behavior world to add your own replacements. So if you have a special game logic where you would like to inject a value into the properties of your loaded worlds, then you can do this by creating a behavior which adds new rules to this solver. And these are simply subclasses of tag resolver rule. As such simply thing, it just has this one function resolve tag, and there it's where it's all doing its magic. So you have a lot of possibilities depending on the needs of your project. The second thing that we have is the extended behavior and state machine, behavior tree and state machine system. So far, behavior trees and state machines did exist, but you mostly use them in script codes with the respective files. In this new update, it has been extended so that a lot of behaviors are now able to add themselves to behavior trees and state machines, so you can directly interact and manipulate the behaviors in your element class using behavior trees and state machines. In particular, this makes it easy to create now pure XML element classes without touching any code, just by making an XML element class, making a state machine, for example, in a state machine file, and just assign the logic in there and having an entire class defined without needing to touch script code, especially for simple objects which do not have complex logic, but you do not want to write script files for, you can use this. In this example, I have two things done. One is that I've extended this extended custom color. In the last time I showed that this can be done with, let's reveal it quickly. Hier, genau. The last time I showed that you can reproduce this class with an XML element class. And this is now an extension of this same element class, but with support for a state machine. So I've added into this element class the state machine behavior and gave it an initial state machine file. So every behavior which I then add after this state machine, like for example a custom color or similar, can then attach themselves directly to the state machine. So it's a good thing to insert or to add the state machine or the behavior tree behavior early in your element class. And then everything that you add as behavior to it will hook itself into your state machine or behavior tree and make itself visible using actions that you can use. So in the case of the logic, I have it here. It's just a simple state machine XML file, which is again an XML file, which is much easier to work with than having some kind of node system in an editor, which quickly gets convoluted and hard to read. This is just a basic system. You have states, you have transitions, you have actions, easy as pancake. So here in this example, I've defined a simple base state, which has a couple of transitions, which are fired if specific conditions are met. So initially, I start with everything disabled and I will enable certain things depending on what kind of color for the red, green, and blue channel has been set by the user for, in this case, color 2, which is the Dragoness color. That's a little bit an artificial example, but it simply shows that I can use a custom color that the player chooses to drive, in this case, a light, a particle emitter, or a speaker. You will find them in this example file below. Here is the light. Since it is added after the state machine, it adds itself with actions named light, for example, light set or light check. This is the logic which I've chosen for, or the naming which I've chosen for all the behaviors. You can use the property prefix, which is used for a behavior. In the case of light, the property prefix is light, and add set, update, or check behind it. And these actions are then used to set a value of the behavior, check a value of the behavior, or with update to trigger some kind of actions on the behavior. This naming is pretty much everywhere the same, so it's easy to know what you will get. Then I've added also two particle emitters. One is, again, a flame, and also is the smoke, which have the ID flame and smoke. And the same here happens then true. They will add themselves as actions which are named particle emitter and in parentheses the identifier of the behavior. So by adding this, you already know how you will be able to treat them: particle emitter, ID, and again set, update, or check. The same also for the smoke, and the same for the speaker, which is the one on the bottom. So what happens is now that using the red color, the green color, and the blue color, I can influence or switch on and off the individual behaviors. So how is this going to look like? So here we have on the back this color choosing example. That's the extended color choosing example of last time. And this one here is the new extended custom color. The editor will detect your XML files and can load it and will figure out what you had in it. You will see, for example, that now it also figures out that there is a state machine behavior which you would be able to change. They have, in general, though, the same values as these others. So you see you have the light in front of it, you have a particle emitter for the flame, you have the particle emitter for smoke, and on top of it you would also have the speaker. Here everything but disabled. The editor does not know about these kinds of state machines. It will not run state machines because the editor is not here to preview or to try to figure out what kind of actions happen with an actual implementation. It's here to define the properties, and so the artists know what goes where and what it is going to do. So we will switch on now the example again, and then we can go back and have a look at this example. So here we have it. Everything is disabled. So I will quickly go here. So, and after the rules that I've seen, I've said if I change the dragoness color, I can switch on the light, the particle emitters, or the sound. So let's try the light one. If it goes above a certain value, it's enabled, and it's disabled depending on the value. That's the state machine doing it. The same for the flame and smoke. You can enable it, and then we will show at the bottom in, on, off, depending on what color I choose. I can also mix the two because it's a state machine, and I could also make the sound. Maybe you have to listen a little bit. You don't hear that well, but it will switch on the speaker. So this way, I have created now an element class which allows an interaction, a state machine which drives like a light, a particle emitter, or whatever, just with files. I have not touched any code. I have just written a state machine file in XML which defines what the logic is. I have defined in my XML element class that I want a state machine with this state machine file, and I have added behaviors to it which then hook themselves automatically into the state machine. The same can be done also with the behavior tree instead of a state machine, which then would be just a file with DEBT instead of DESM, but the system is the same. The same actions that are available to state machine are also available to the behavior tree, just with a little bit extended logic, because in behavior trees, actions can also return a running state and not just success or failure. So you can choose what you need to do your thing, and you can also max them. So you can have one or more state machines in your object. You can have one or more behavior trees in your element class. And you can even have both at the same time. So you really have all kinds of possibilities. And the good thing is, most of the time you can just go on by using files, and you do not need to go into the script unless you want to make a new behavior which has your personal custom abilities which you want to add to a game. So while you can do this for objects, you can also extend this to the logic. So we have here this cowardly actor AI, which is this little guy which will run away from you when you get close. That's the implementation of the AI which drives this actor in script logic. The same you can do now also with a behavior tree of files. At first, you need a behavior which contains all the actions that you can drive. That's this one here, where I've added all the behaviors. It's actually the same behaviors which are also used in the script only example. So this is not something new, but it's put into a behavior with the name default behavior AI covered. I have also created a factory for it so that I can add it in an XML file. And in this factory, I will also add it to all the stuff that I'm needing it. As mentioned in the comments, there is a shared factory helper class, which has been also shown in the last time, which you then can use to make this process easier. You then just have to make sure that this file is added to your example app. So where you are adding behaviors and factories, you just have to add all your behavior factories so you can use it in XML files. So once you have this added, you can then define in your element class that you are going to use a behavior tree for your element. This works because by default, a BAA behavior tree AI is assigned to your element class, which is using the behavior tree, which is part of the basic actor. So the basic actor already has a behavior tree and a state machine added for you as behavior. You can just use it and extend it. So in this case, it's the cowardly XML behaviors, which means it's the same behavior which I've been used for the scripted case. So nothing new, just at this time, I've used just an element class to define this element called cowardly actor 2, and the rest is the same. Just adding some parameters. You can look at this on your own leisure, but pretty much it's just defining some behaviors, properties, and the rest is then done by the behaviors orchestrated by this behavior tree file. By the way, it's here called cowardly XML. Usually you would use the file extension DEPT for Dragon Gene Behavior Tree, but it's actually up to you how you do it. I would say better use it, but since this is an old example, I stuck with the XML extension, didn't change it. So pretty much this works as before. I'm not going to show this because that's the same. And you can also extend this to the player. So I have used, for example, the player that I have also shown in this example has been driven now by a behavior tree and a state machine instead of script code. So the previous example, I created a actor class. Here I still use a script class for this because a couple of things are not so easy to make with an XML class, especially some kinds of bindings. But in general, it would also work with a pure XML element class. Then I've said that as factory, I use here, this one, it's already, you don't need this. It's the BAA state machine action, which then uses the player DESM state machine. So for the state machines, it's like this. I have provided in the game engine a couple of pre-made files. You will find them in the shared data, which are available to every running game. And they are called state machines, actor actions, for example, first person or vehicle DSM. And they provide a basic state machine implementation, which is useful for a first person actor or a vehicle. You can import them into a state machine and use them. This is a nice ability or nice feature of the state machine system. You can import also state machines everywhere in your state machine. You can import them in your states, and you can even import them inside transitions. This allows to make state machines or to build state machines using a composition logic in workflow instead of an inheritance workflow. So you can create individual parts of your state machine as individual files and reuse them by importing them at the relevant parts. This makes state machines much easier to write, much easier to understand, since you don't have to repeat everything in all places. If you want to do this with the state machine systems in other game engines, you get a huge noodle soup because you have to duplicate everything. You have to try to work with like groups, making it hard to get it working. Here, the logic is simple. Import just means take the content and put it here as if it has been written where the input is stated. This also means you can easily change the order. Like all enter actions are done in the order imports are done. So earlier imports are done first with enter actions. They are done later with exit actions. And with transitions, it's the one which is earlier which wins over those which is defined later. So it's easy to understand what kind of overwriting happens. Here I've also added a player shared, but that's just inside the example app, a little bit something where I say, these are the interactions I use a couple of times, I can share them. A lot of commentations, the initial state created, which is defined by the underlying player first person DESM file, which is provided by the game engine. If you define a state which exists already in the base state, it is overwritten. So it's easy what you get. And if you want to keep it, you can also import the previous state and then use it. So in this case, the ground state I have created myself. It will replace the ground state which has been already imported. But I can say I want to import the ground state again, so I extend it. That's just how states are extended. And otherwise, it's the same. I can define transitions with the event, where it is going. I can then, for example, import in a transition typical actions that I want to carry out, which then again means I can share state machine parts across different state machines in a clean and easy to understand way. So it's usually will all end up then with a kind of shared state machine file for your company or for your working team, where you then put in your stuff you want to use in other state machines. You can just import them. I'm not going to say too much about it. It's better if you read the comments, if you take a look at it, take at the files inside. But basically, what is written in this state machine is the same as is written in player actions. I've kept these files around so you can compare them. Here it's just working with inheritance, where the actions inherit from other actions. So in an inheritance-based workflow, whereas the state machine one is then a composition-based workflow. Interactions are then done using also state machines, for example. So this XML, please. I can define then individual state machines which handle individual game logic. So I do not have to write one huge state machine which covers all, but I can switch between state machines for the same actor to change different logic it's going to perform in each situation. So in this here, I'm looking at the toggle logic. I've said, okay, if we have a primary interaction is defined as a binding you can use in your project, which is typically the left mouse button or something similar. But you can use any kind of event here. You can even send yourself these events to the state machine, whatever fits your project. So we have defined here multiple transitions, but with the conditions. So here we say this primary action transition is only going to fire if we are using or if we are evaluating the look at behavior. We have again the name look at and the check noun. And we want to check if we are looking at an object, the object has an interaction named toggle, and this toggle interaction returns true. So we can evaluate, is this an object we can toggle? And only if this is the case, we will then carry out the actions, which means we are going to store the element we are looking at as an interaction element. This allows then other actions to easily use elements we found, even if we are no more looking at it anymore. And we are going to change our AI action to a state machine one. So action state machine means switch to a new state machine, and there we are. It's this one here. Then rinse and repeat. So if this action is then finished, I can also go back to the player state machine. So what is this now? Here is the old script-based interaction for toggling an object. So that's how it has been done, or how you would do it using a script. And this is how you then would do it using a script file, or a state machine file in this case. So it's pretty much the same. You have the states you are going through, and you have the actions you can toggle, like the occupier, which would be the same as saying, let's see where it is, occupier. Here, where you say you claim the occupier, that's just done with a occupier update or setting some actions to a new state machine. For example, if you can't occupy an interaction slot, and so forth. With this, you can then manage and control the behaviors in the actor, and you can control the object you're interacting with. And that's done with the interact element exception, or interaction type of behavior. So interaction element is a behavior which you can add to an element class, behavior interaction. And this allows to register one or more interactions that you can do with this element class. You can do this all on your own, you can write it your own, but since this is a common problem to solve, I've provided an implementation already in the game engine. So the behavior interaction is nothing but a collection of interaction instances that you have assigned, and an interaction is simply either do something on an element or to query if an element can do something. For example, I've used this in the Epsilon game project to check, for example, if an object an NPC is holding in his hands is able to be used or not, or checking if it has users left or if it belongs to him or whatever. That you can do with the interactions. And what you need is usually a custom behavior. In this case, it's the behavior interact toggle. And this behavior will simply add in his init section, or can be in the constructor, doesn't matter, add its interaction to the interaction behavior with a particular name. And the name you can choose yourself. So here, its interaction is called toggle, and the interaction that is triggered is this implementation of the interaction interface, which then just does toggling. Optionally, you could evaluate the parameters. This would allow you to a little bit influence what the interaction is doing. You can also see who is trying to interact with you, and you can then return true or false, which is especially interesting for queries. So that's how it is then done. When I'm in the player, you can then just check, okay, do I have this interaction toggle? And yeah, that's pretty much this. That's the name of the interaction, and it asks, can I do this interaction? And if this interaction can be done with the element, or it is present, then I can start with my action. You can look at what behaviors add actions and conditions to statements of behavior trees using the wiki page. On there you find the section about behaviors explained from A to Z, or explained by use case. And then you can search something like, for example, animated, and it will have a section about behavior tree actions and behavior tree conditions, and they outline what kind of actions are added by this behavior and what parameters you can use, as well as a little example that you can copy paste into your behavior tree or state machine. You have the conditions which are added. Conditions are similar to checks. The idea behind a check is that if you are in a behavior tree, a check is usually a possibility to make a sequence work or not work, because a condition is always used to always interrupt an action if the condition becomes false, and the check is useful to say, can I even start a sequence like it's written here? Make a sequence, check if the condition is true, then you can continue with your sequence. But if the condition becomes false while you are in the sequence, not a problem, you are not thrown out, but with the condition you would be thrown out. For the state machine, you have the same actions and conditions as outlined above, and in addition, you have events. So behaviors can send events to your state machine. Like if the animation starts or stops, you will get an event in the state machine and you can react to it. Below, it's usually then also an example how the behavior factory would look like. Usually you do not need the optional at all. The behaviors are written to add themselves to behavior trees and state machines if they have been already added before themselves. So just add state machine behavior team at the beginning, add the other behaviors, and they will automatically add themselves to them. You can also, if you are in the Visual Code with the DragonScript plugin installed, hover over any kind of class, which is, for example, behavior interaction, and it will then show at the end a C section which links directly to the page where you then have the behavior trees outlined. In this case, there is none, but if you, for example, use something like, let's say, navigation space, you would then end up in that place where you can look at the information. That's not a good example. Animated I wanted to have. That's the one we've opened up, behavior animated. That's this one. So all the classes will have this in their documentation section. So I hope with this example you've got a little bit of view into the new system of ECBehaviorWorld and behavior trees and state machines for elements and player use. This system especially is useful for your coders and scripters so they can stay with what they like the most, working with files, working with code, working with XML to do all the logic without having to touch the code. And modders too, which do not need to touch your code all the time if you want to add simpler logics to your game projects. So with this, happy coding and happy game deving, and hope to see you next time. See you!